In this video, we will be discussing the second type of compound inequality, which we refer to as and or intersection. So recall from day 7 that a compound inequality is two inequalities that are joined together. There are two types of compound inequalities, but we're going to focus on the second one today, which is called an and problem. So the solution to an and problem must satisfy both parts of the inequality, whereas with the or, it only had to satisfy one part. So if we have this example here, x has to be greater than 2 and x has to be less than or equal to 5. So it has to satisfy both parts. So to graph this, we're going to have an open circle on positive 2 and then a closed circle on positive 5, and it has to be greater than 2, which would be to the right, but less than 5, which would be to the left. So basically, the only thing that would work are the numbers that are in between those two numbers. So you're only going to shade in between your two numbers on the number line. So the interval notation will not have any infinities with it because it's just going to be from positive 2 to positive 5. Notice there's a parenthesis with the positive 2, but a bracket with the positive 5 since the positive 5 has a closed circle. We can also write and problems in two different ways. So we can write them as two separate inequalities, or we can combine them as one large inequality where x is in the middle. So you're going to see them written both ways in the homework and on the quizzes and the tests. So it's important that you understand that and can be written in more than one way. So let's practice just graphing and doing the interval notation with these first two examples. And then with the last 4 examples, we're going to solve, graph, and write the interval notation. So in example 1, again, think about on a number line, which number would come first. So negative 5 has to come first, and then positive 6. They both need to have closed circles, and they have to satisfy both inequalities. So it can only be the numbers in between negative 5 and positive 6. So I would have bracket negative 5, comma, positive 6 with a bracket for my interval notation. In example 2, again, this is one of the other ways to write an and inequality. So on a number line, negative 2 would come first, then positive 1. The negative 2 has a less than or equal to symbol, so it's going to have a closed circle. The positive 1 is going to be an open circle, and you're going to shade everything in between those two numbers. So I would have bracket negative 2, comma, positive 1 with a parentheses for the interval notation. Okay, so sometimes you're going to actually have to solve these and then graph them and then write the interval notation. So let's practice solving them when it's written as one long inequality. So I want you to think of the inequality symbols as kind of like two equal signs. So I'm going to draw dividing lines here. And you want to get x by itself in the middle of the inequality. So to get x by itself, I need to get rid of this positive 3. So I'm going to subtract 3 to get rid of it, and you have to subtract 3 on all sides of the equation. So you're going to subtract 3 on the right, but you're also going to have to subtract 3 on the left. So 9 minus 3 gives me 6. Bring down the inequality symbol, less than or equal to x. Bring down the other inequality symbol, which is less than or equal to 11 minus 3 is 8. So on my number line, positive 6 would come first, then positive 8. They both would have closed circles, and for and, you shade everything in between. So I would have bracket positive 6, comma, positive 8 with a bracket for the interval notation. Same thing with example 6. It's written as one long inequality. So we're going to draw our two dividing lines. And we want to get x by itself in the middle. So first thing we would do is add 20 to move that out of the way. So make sure you add 20 on all 3 sides. So I get 0 is less than 4x, which is less than or equal to 28. Then you still need to get rid of that 4. So we're going to divide all 3 sides by 4. So I get 0 is less than x, which is less than or equal to 7 once it's solved. So on a number line, 0 comes first and then 7. Open circle on 0, closed circle on 7 since there's an equal bar, and then it has to be shaded in between. So it would be parentheses 0, comma 7 with a bracket since the 7 has a closed dot. All right, let's try these last couple examples. So for example 7, again, it's written as one long inequality. So we're going to draw our two equal bars. And then first thing you're going to do is subtract 4 from all three sides. So I get negative 3 is less than 3x, which is less than 6. Last thing I need to do is get rid of the 3. So divide all three sides by 3 to get negative 1 is less than x, which is less than 2. Once it's solved on a number line, we're going to put negative 1 first, then positive 2. They're both going to have open circles, and then the shading is going to be in between those two numbers. Then for the notation, we would have parenthesis negative 1, comma 2 with a parenthesis. The last example, example 8, notice that this and problem is written as two separate inequalities. So that's the other way of writing an and compound inequality. So again, we're going to just solve them separately if they're written as two separate inequalities. So for the first one, you're going to divide both sides by negative 4. And because we're dividing by a negative, we're going to have to remember, flip the sign here. So I get D is less than negative 2 as the first one. And for the second one, we're going to distribute the 3. So I get 3D plus 9 is greater than negative 12. To keep solving, subtract the 9. So I get 3D is greater than negative 21. Then divide by 3 last to get D is greater than negative 7. So on a number line, negative 7 has to come first and then negative 2. They're both going to be open circles, and then you're going to shade in between. So the interval notation would be parenthesis negative 7, comma negative 2 with a parenthesis. Okay, so hopefully now you have a better understanding of compound and inequalities. Just remember that there are two different ways to write an and inequality. You can write them separately, like example 8, or you can write them as one long inequality, like example 7. Either way, you'll get the same answer in the end, no matter which way you write it out. Feel free to ask your teacher if you have any additional questions on compound and inequalities.